Thanks to you and to Jason and the entire CJEP team that pulled together this tremendous event. So the surge in electric power demand in the United States is one of the hottest topics, if not the hottest topic in energy policy in our country today. For most of the past couple of decades, there's been almost no growth in electric power consumption year over year. Then last year, electricity consumption grew by 2%. Analysts are now projecting 2 to 3% growth steadily over the next couple of years, which means by 2030, we could easily have 10 to even as much as 20% growth in electricity consumption in the United States, which is more than we've had in many decades. So why is this happening? There's a number of reasons. The growth in manufacturing has been a big factor. The growth in electric vehicles is a factor. But the single biggest factor is the growth in electric power demand for data centers. And why is data center demand growing? Well, there's a number of reasons. Data centers do a number of things. They power bank accounts, they power 5G networks, but the single biggest factor for sure is the growth in demand for AI. And so this confluence of AI demand and electric power demand is such a hot topic. I think 2 of the 5 panels or 2 of the 5 sessions this morning in this energy conference have been about this. We had a tremendous conversation already with Jonathan Ross and Vijay Vaidiswaran. And actually at this moment, our colleague Dave Turk, who's a distinguished visiting fellow at the Center on Global Energy Policy, was Deputy Energy Secretary in the last administration. At this moment, he is testifying before a full hearing of the Energy and Commerce Committee on exactly this topic. So it's a really hot topic, and we have an amazing panel of experts here to talk about it. They've already been introduced. And we're going to talk about demand, we're going to talk about supply, we're going to talk about flexibility resources, we're going to talk about how AI can help improve the operations of the grid. And let me just start with Kathleen Barone from Constellation and ask you about the demand profile and what's happening in Constellation's service area. I learned looking at the website for Constellation in the past couple of days. Constellation's in 48 states. So when you talk about Constellation service area, that's a really big area. So what's happening in Constellation with respect to power demand?
Yeah, and good morning, everyone. It's great to be here. We are a large power producer. We have assets in about 19 states, and 90% of our output is carbon-free, and that's due to the wind, solar, hydro, but mostly to the 25 nuclear reactors that we own or operate across the U.S. So we are receiving a number of inbounds from parties across the spectrum who are looking to help service this data center demand that David mentioned. And I do think there is a lot of attention. You mentioned the congressional hearing, all the RTOs, NERC, are looking at what does this really mean in terms of impact on the system. And the numbers really do vary widely. And they're all sort of pre-tariffs, pre the market condition that we're in right now. But if we do end up with 10% compounded growth in a decade, that would not surprise any of the folks that are looking at this issue. And it's not just data centers, as David said. There's been a move towards electrification and reshoring of industry, and a lot of that load growth is in those numbers. But I think it has been a challenge for some of these entities to actually project how much is actually coming. And I'll just give you one example from one of our service territories where, it's a large metropolitan area where there's been a lot of attention given to this issue. But in order to get into that queue, to put your name in as someone who wants to build a data center, you have to own the land, you have to fill out a form, and you have to pay $1 million deposit. And given the cost of some of these facilities and given the impact they will have, both on the communities in terms of jobs and economic growth and on our country and our ability to win the AI race, that is not a very high hurdle to meet. So I think, and Melanie hopefully back me up on this, there is a fair amount of double counting in some of these load forecasts. And that is a challenge for people who are trying to project ahead as to what we will need in order to meet the demand. And I think that's where some of the, David mentioned the idea of flexibility, some creativity among those of us who are responsible for operating this power grid is really going to be needed. We have to meet this load. We have to be able to do that. We have always done that. There was times when load growth was way larger than 2% a year back in the 50s. 8-9% a year. We all know why that was happening. We met it then, we can meet it now, but we are going to have to work hard at how to get the efficiency out of the system that's there and that's latent that we haven't been using when demand growth was flat.
Michael, I know you've been thinking about this topic as well, and you know, I think a couple of years ago, not everybody in my professional world knew the phrase Jevons paradox, but I feel like today everybody's talking about Jevons paradox. Could you just say a word about how you see the efficiency improvements in chips that we already heard about this morning from affecting the overall demand for AI and power in the years ahead?
Sure. Thanks, David. And it's great to be here. Jevons paradox is basically a fancy word for saying that as a system gets more efficient, we find new use cases for that system. Since we're at a university, to use economic speak, it's saying it's an elastic demand curve. So I think one great example to think about Jevons paradox is video streaming on the internet. For those of you who can remember the dawn of the internet and real networks experimenting with how do you get pixelated pictures through to people's computers, to what we have today of walking around with supercomputers in our pockets and the amount of data that gets put over the airwaves, we came up with extraordinary new use cases for all this data connectivity. I think you'll see the same thing with AI. You're seeing NVIDIA continue to drive efficiency through their chipsets as we start exiting the end of the H100 era and we go into the B200 era. And a couple examples of use cases we're seeing come through our portfolio, they kind of get outside of just the large language model era, is robotic applications and also machine-to-machine applications. So it's one thing for those of us to write a prompt and have the LLM respond to us. It's another thing when you start having two LLMs talk to each other, and you can start seeing how that demand can go very quickly. Also, robotics. Right now, the limiting factor on most robotic applications is the refresh rate of the AI. And so as we're able to accelerate AI, naturally you'll see additional polls and tokens generated to increase the hertz rate of robotics.
And so you foresee the growth continuing even with efficiency improvements in GPUs, you see overall electric power demand growing?
Right now, the limiting factor on AI is not demand. The limiting factor is currently chips, and most people expect shortly it will become electricity.
I mean, that's consistent with the idea that Jonathan Ross was putting out this morning for those who were here. Kind of there's an infinite demand for intelligence, and we're going to keep on having demand for intelligence. And but one aspect of this I'm wondering about for overall power demand in the United States is the possibility of a recession. And so the S&P is, down 19% from its peak, and NASDAQ Composite is down 24% from its peak. I saw J.P. Morgan estimating that the odds of a recession are around 60% right now. So I don't know if actually anybody's thought about this, but if we do go into a recession in the United States, how does this affect this overall picture? Anyone? I thought so I've begun to think about this. I'll answer my own question and then we'll move on. I did a little bit of research on this and looked and saw that in the past two recessions in the United States, electric power consumption went down slightly more than the rate of GDP. So in the Great Recession, it was around 3%. And GDP fell by around 3%, and electric power consumption fell a little bit more, according to one study that I saw. So I think there's at least a possibility that there'll be downward pressure as a result of a recession, maybe affecting manufacturing and other types of electric demand. However, if demand is being driven by AI use, and there's an almost infinite demand for intelligence, maybe we won't see that type of impact in a recession coming up. So I think there'll be analyst notes coming out on this topic. It'll be very interesting to see.
Yeah, we're busily trying to re-rate our view on what demand will look like after the events of the last week. And I would say, since electricity was going to be the constraining factor of the hyperscalers or the big AI companies, right now their data center real estate strategy is power access. And so if suddenly a lot of other people are exiting the line, they'll be happy to move forward in the queue.
Well, let's turn to the supply side of this and what resources we're going to use in order to provide this electric power in the United States, and turn to Melanie Nakagawa from Microsoft, one of the major customers for this electric power. How do you see the division of resources, natural gas, renewables, nuclear, and you're the Chief Sustainability Officer of Microsoft. How do you think about the sustainability impact of providing all this electric power?
Great, well, thank you so much for the question, and it's great to be part of this panel, especially with such great partners. And it's not planned, but it's a good segue to how we think about the range of power sources and fuels that we're using as we think about both the demand and supply of hyperscaler technology and how we power our data centers. I think first and foremost is looking at where we're gonna go build data centers and grow that demand to meet this intelligence economy that continues to grow and the need for compute resources, let alone generative AI resources, is to ensure we're bringing more power to those systems and more power to those grids where we're adding load. The second piece is how do we do that and ensure as much of that is as carbon-free as possible? We have a goal to match all of our load with 100% renewable energy by 2025, by this year, and we're on track to do that. And one of the things to do that is ensuring that as we grow load, we're growing the role of power purchase agreements as well. So to date, we've done around 34 gigawatts of PPAs in over 24 countries to try to do that matching by the end of this year. And the third area is to ensure we're paying our way through this whole process. And so, just to give an example, and because you're sitting to my left, last year Microsoft and Constellation announced a partnership to restart 3 Mile Island, the second reactor, I believe, and Unit 2, and it's around 800 plus megawatts of carbon-free power coming into a grid that we know is where AI load is growing. It's a congested grid, and we want to be adding more power and capability, and ideally as much of that being as carbon-free as possible. And I think your number was 90-something% of your total load is carbon-free. And so I think that's just a great example of how we think about how we bring on more supply from a range of resources. We think about this in those PPAs that are mostly wind and solar, the work we're doing within nuclear assets as well, and then thinking around about natural gas, how are we looking at carbon capture technologies alongside some of those facilities as well to mitigate the emissions impact of that as well. So it's sort of looking at a range of these options, but really fundamentally on bringing on more power to those systems, ensuring as much of it can be carbon-free, and ensuring we pay our way through it.
Yeah, if I could just clarify, it was the undamaged reactor at the 3 Mile Island that, that with Microsoft's long-term contract, we will be restarting. And so the question is, why is it being restarted? Why did it shut down in the first place? And in 2019, it did shut down for economic reasons alone. It was a very high-performing asset, putting 835 megawatts of carbon-free power around the clock onto the grid, but we did not have federal policy that supported nuclear, and we had very low prices in the market, and you had renewables receiving state and federal subsidies on one hand, and fossil not bearing any cost of pollution. So you did see across the country 13 reactors shut down, and because of this contract, this one will be restarted. There aren't a ton of those opportunities out there, but to the point about using more of the system to try to meet the demand as we see it coming, there is the opportunity to what we call uprate many of the nuclear plants. Across our fleet alone, we could get 1,000 megawatts out of the existing stations. So no new concrete, no new land needed. That's like a whole new reactor right there. And then in addition, what we really think is the opportunity here is to relicense the stations for another 20 years. That is not something that we can do by ourselves. We need to have NRC approval, and we need to make the capital investments necessary. But with some sort of long-term contract from a data economy customer or otherwise, that's 20% of the nation's energy coming from nuclear power right now, 500 million metric tons of abated carbon, staying on the grid another 20 years. That's something we can do right away, and we can hopefully meet the speed need from the customer base to get these training data centers up and running as quickly as possible.
I just want to chime in on that. I think one thing that you're talking about between where we are today, I think these turbulent times, right, the geopolitics of the world, it's also, I'm an optimist, so I'll put my bias on the table pretty bluntly. But the reason why is I think it's an incredible moment right now for innovation and opportunity when you have areas of constraint. And so another example is how do you use data centers to provide waste heat and provide that back into grids and the communities around. And so we've done this in a couple of the regions in the Nordics where we can take the waste heat and it powers thousands of homes. But it's that kind of innovation of looking at resources that already exist. How do you better utilize existing resources? I'm sure we'll get to it later, but how to use technology and the output of these data centers like AI to just further advance and enhance these systems. But I do think it's these moments where there's incredible opportunity where the economics start to make sense, even more so, like in this case, but in so many others, you're starting to see the economics really turn towards how to accelerate the transition because it's the right economic decision to make.
Let's park that important topic for a minute, because I want to bring in Ashley on nuclear in particular. Ashley knows more than a little bit about nuclear power. She's got a PhD in nuclear sciences, I believe. Ashley, any thoughts about the potential for nuclear in the United States in the next decade, broadly speaking?
Yeah, absolutely. And as it relates to AI and the demand for compute, I mean, I'll speak a little more broadly than just nuclear. I think that AI and compute have enormous potential to help drive us towards our long-standing energy goals of security and clean energy and reliability. And that's both as a catalyst and as a tool. As a catalyst, the demand for energy, is my mic making a ton of noise?
I think it's good.
Sorry. We've had several decades now, or a couple of decades, of tepid demand growth and really strong policy efforts, and we've made modest impact on our goals, but inadequate, right? And I think we've heard about that this morning. If I'm optimistic that the combination of an economic push, and Michelle was alluding to this and stating this, an economic push combined with that policy work can be transformative in helping us meet our policy goals. And that applies to nuclear as well as other clean energy sources. So this urgent demand for clean, reliable power from data centers and a higher willingness to pay for those services is making a lot of the energy providers, including many nuclear companies, very optimistic that this demand will help move them through the valley of death and to their first of a kind and to nth of a kind products that will ultimately be competitive in the bulk power market, but immediately could meet the needs of this market. And then I think AI as a tool has the potential to be transformative as well. So it can help us with R&D related to new materials, related to new battery chemistries, but then in nuclear specifically, related to nuclear design, accelerating nuclear regulation, and even accelerating nuclear construction. Michael mentioned robotics. Robotic welding could be transformative in nuclear construction. So a lot of potential as a catalyst and a tool to really move us towards our energy goals, including nuclear goals.
Could I ask about small modular reactors in particular? Because I've heard optimism about SMRs, but when I ask the optimists when they think the first SMRs will be available to actually provide power, the answer is usually 2030, 2032, somewhere in that range. Would you agree with that assessment?
I think that's relatively on target, but we have other nuclear that's available sooner. So I think Kathleen mentioned uprates. Uprates of the existing fleet can be available much sooner. We could see restarts like TMI or Duane Arnold or Palisades happening faster than some other projects. You could see the completion of VC Summer. That's another 2.2 gigawatts. So you're talking about between 2 and 12 gigawatts here of really quickly available nuclear. And then additional reactors on existing sites, again, quicker. But yeah, 2030 is a reasonable time frame for SMRs. Some would say a year or two sooner, and some would say later.
So one more nuclear topic, because Michael, I know you've been investing in fusion, and very interested in your take on the potential for fusion and the time frame.
Yeah, one of the privileges of investing permanent capital is we get to look over the horizon and see where we think the world's going. And the physics hasn't changed around fusion. Most all energy we consume originated in fusion in the sun. And so the question is, can we shorter the number of energy transitions and put the star in a bottle? And fortunately, there's been a lot of non-correlated technology advances, materials, advanced compute. They give humanity a much better tool chest for figuring out fusion. And so a couple examples in our portfolio, Commonwealth Fusion Systems. Their core innovation is high temperature superconducting magnets. And so as we have more HCS tape, We've got the ability to build better magnets, which makes it easier to contain a plasma. On the other end of the fusion family tree, Excimer, which is inertial fusion, is working on concentrating laser energy using gas-based mirrors rather than glass-based mirrors. So it's 60x more effective than the traditional ways that NIF did it out in California, and gives us hope that in the next 10 years, we'll see commercial fusion on the grid. And I think within this presidential administration, we'll see Q greater than 1 and potentially much greater than 1.
And I guess a question on time frame beyond that as well, because when I talk to people, optimists about fusion, they say there's a lot of potential here, but the earliest time frames I've heard for fusion being commercially available are in the mid-2030s. Is that consistent with your expectations?
I think that's generally correct,
Yeah.
It's not going to fix our near-term challenges, but as we try and look to the 2050 targets, it can be a significant contributor.
So let's talk about renewables for a moment and then go to the kind of how do we use data centers for flexibility on the grid. But I was at CERAWeek, and I think Dan Yergin is here. It's an amazing conference, as always, and the CEO of NextEra was on stage there, and he said on stage with Dan that the fastest way to get power online to service data centers is renewables plus storage with a little bit of gas backup. Is that consistent with what any of you were saying? I see, Kathleen, you're nodding. Would you agree with that?
Well, my CEO was also on stage at CERAWeek, so I might want to
sorry, I
quote
didn't
him
see
rather
it
than
much.
John Ketchum. But yeah, that is what John said, and I think that's right. I mean, renewables can be built quickly. There's no question about that. There are supply chain issues with all new types of generation, and so that is true across the board. But I mean, they are quick to build. They don't sort of stay on the grid as long as some other types of assets do. You know, if we're talking about a near-term need, then we have to best utilize the existing system that we have, and we are seeing customers look to, you know, for the reasons Melanie identified, their internal goals or otherwise, to renewable power. The question is, you know, we have a broader grid to serve, and we need assets that run when, you know, it's super cold and super hot, and when the sun isn't shining, the wind isn't blowing, and how do we do that in a way that's also sustainable, I think, is the big challenge.
Please.
And I think on that point, though, the other piece that many of you, especially in this audience, know is the role of that untapped capacity that exists today, right? And so the fact of how do you use technology and solutions to help improve existing transmission systems. So as much as we need more transmission systems, more power coming online, there's also a lot to unlock within the existing transmission system. And this is where, you know, there's been a growing conversation I think is much needed about just making these systems smarter. Digitizing these systems, making them smarter, giving utility providers, frankly, better means to understand and communicate and, frankly, optimize very complex systems, such as moving power through grids. Microsoft has $1 billion climate innovation fund. We also invest in a variety of technologies that we're going to need commercially viable by 2030 and then beyond, not just for ourselves, but for the world. And so we get a chance through that process to look at a variety of portfolio companies to see what are some of these technologies we believe are commercially viable today or commercially successful today. Two in particular that go to the idea of how do you unlock today load and capacity. One is Line Vision. Line Vision is a company that does dynamic line rating work, and they piloted their work. They're actually in New York, so it's an appropriate example to use here, sitting in New York City. But they also are in the UK. And when they tested their system out there with UK National Grid, they showed that they could bring on 60% more capacity onto an existing transmission line, which in that case was around 600 megawatts of offshore wind power being able to move. And so that's just a great example of if we can use this type of technology to really understand and measure and optimize these complex systems right now by getting the right policies in place and others to digitize and just make these systems smarter, we can start to unlock some of this untapped capacity that already exists today. And I think that's another key part of some of that near-term needs that we all have.
Yeah, if I could just build on
Kathleen,
what
and then
Melanie
ask-
said, I know it's probably blasphemy to cite a Duke study when you're at Columbia, but I would commend to you a study done by the Nicholas Institute at Duke University, which gets right to the point Melanie was saying about exactly how much untapped capacity there is on the system between transmission, distribution, and generation. You know, just one statistic for you, 80% of the hours, 30% of the generation is sitting there doing nothing. We have a lot of excess energy on the system, and we often conflate energy and capacity. We do have to be able to meet the system need at peak. But if we can introduce some flexibility into how the loads use the system, we can unlock a lot of ability to add new load without having to add new generation that's going to sit there and be on the customer bill, but not actually be running. And so this Duke study goes through exactly what the numbers are behind that, and they come out to about 70 gigawatts of new load that could be added if we have flexibility for just 0.25% of the hours. That's a handful of hours across the year. So that is a really important challenge for those of us in the industry to make sure we are finding the solutions like what Melanie mentioned and others. And some of them are going to be policy related, and some are going to have to be how we operate. But a lot of them are technology, and that's the beauty of this sort of peanut butter and jelly type of moment we're in between the energy suppliers and the consumers to try to tap into that.
We recommend that Duke study too, by the way. All contributions to knowledge are welcome, even those that aren't from this university. Ashley, you've been thinking about this topic as well. Any thoughts about how we use data centers to promote flexibility on the grid?
Absolutely. I mean, I think there's enormous potential, as Melanie and Kathleen just described, to use data centers to bring in better use of variable renewables and distributed energy resources. It's a great opportunity. It also introduces new attack surfaces for our grid. So it has the potential, the use of AI for grid services has the potential to introduce vulnerabilities. It also has the potential to make our grid more resilient. And I think it's important that as we develop and deploy these technologies, it's possible to do it in a way that makes our grid more resilient, and it's imperative that we do the work to make that the outcome.
Just to follow up on that security point, because it's so important, what steps do you think we can take to make sure that we're maintaining security of the grid and safety as we deploy AI on the grid?
So it's interesting that, and Kathleen may know much more about this, but FERC and NERC, they have a lot of good cybersecurity regulations in place and guidance. In the more distributed space and regional smaller generators that aren't regulated by FERC and NERC, there's NARUC is doing some work on this, but they don't have the same requirements. And so we'll have to just figure out how do you incorporate those resources as something that can make the kind of difference that Kathleen was describing without introducing vulnerabilities. And I think that it can be fantastic. We can have resources that can be brought together to support where a grid is otherwise going to go down, to help with black start capability, to do really resilient things. But there are some regulatory and policy issues that probably need to be addressed to make sure it moves that direction. I wonder if Kathleen has thoughts on that.
I mean, I am not an expert on that. I was at FERC when we were implementing the NERC standards coming out of the Energy Policy Act of 2005. So I am aware that these standards exist, and I have just a hunch that they are going to keep up with whatever issues are being presented. But just to be clear, the kind of flexibility that I was talking about and Melanie was talking about, I don't think are implicated by that. I think that the security that we have on the grid is robust and will stay and will, for example, the operation of power plants, when they dispatch on and when they dispatch off, who has access to them, none of that is changing.
Right, and maybe it comes more into play, sorry, when you get to non-conventional resources like calling on the electric vehicle charging infrastructure. That's a little bit different, right? But we have to be thoughtful.
From a security standpoint, you mean?
Correct, yeah.
Yeah,
Michael?
one point I often make when people ask about flexibility in data centers is that if you were everything else being equal, data center is not the first thing that you're going to shed the load on, because the gross margin on that electricity spend is extraordinarily high. Yeah. There's a lot of other use cases of electricity that the gross margin is a lot smaller that you would want to shed first. However, the data center operators are desperate for speed to power. And so if there's a way to say, we're going to connect and manage, rather than saying your interconnection is going to start at 9 nines and be Cadillac level service right out of the gate, if they can accept something that's more like a Camry, or I guess in our trade era, maybe I should use a GM brand, but I think there's a big opportunity for policy to be a part of accelerating the interconnection, to just say, let's change the service level. It's not the first thing we'd probably shed, but in order to get you connected quicker, let's adjust what we usually would sell you.
Yeah, speed to power has certainly been a mantra. Are we seeing that type of thing in the market right now, where data center operators are coming in and saying, I'll accept something less than 5 nines in order to come on quickly?
I mean, it may be a question for Melanie. I do think what matters is what the backup generation looks like, and so that would affect the economics, given the amount of investment that's going into these pieces of equipment. But there is an active conversation going on at the policy level in many states to get right at that question.
So, Michael, I know you're investing some as well, or even looking at investments in this flexibility space and demand space. What are you seeing, or what are your thoughts on potential for startups in that area or revenue in that area?
Yeah, I mean, there's extraordinary opportunity for using AI for how do you better dispatch batteries. There's an interesting example down in ERCOT earlier this week that they've had a huge boom in battery builds, and they were dispatched overnight when the sun's not shining, and they were empty in the morning when they had a cold snap and power prices spiked to 4,000. So if you can integrate different data sets, including weather forecasting with your battery dispatch, you should have discharged slower so that you could still have some gas in the tank or charging the battery when that cold snap came the next morning. We're also seeing huge opportunities for managed charging for electric vehicles. I think this is a really acute problem on the distribution grid because typically people buy electric vehicles as a social herd, and when your neighbor gets one, you're more likely to get one. It can put a lot of stress on the local distribution system. So being able to use software to smooth out those spiky demand curves is going to be really important. I had an interesting moment personally 2 years ago. My neighbor's feeder line melted in the sky because it was hot, running air conditioning, cooking dinner, charging his electric vehicle, and the conductor just couldn't handle it. So being able to move the charge rate of those batteries not only helps optimize the system, but it's also a big safety concern.
I want to move to policy now and kind of ask generally what your thoughts are about the optimal policy framework for promoting these types of changes. I'll throw it open. Anybody would like to comment?
I could start. I mean, one area is figuring out how do we help expedite these systems and how do we become the best advocates for the policies that actually move forward really smart policies that expedite these systems, and the role that a variety of things use, of course, I'm going to say technology, which is just a no-brainer. But one of the examples we've been looking at is how do you help accelerate the permitting process for many of these technologies that are oftentimes quite complex permitting processes, lots of different rules and regulations come together so that you could create that single permit application. Nuclear is a great example of this. And so, what can we be doing? We've partnered with a nonprofit called TerraPraxis to look at how do you use generative AI to help nuclear developers get faster to making that permit process happen and create the first draft of that permit and then move that forward into the system, because it takes lots of different scientific information and regulatory information, and there's ways you can use that. And I think thinking about how government leaders and policymakers can see the role of these types of digital solutions to help them better move through their processes as well, I think is really important. So that's just one area where I think there's an opportunity there, as well as being advocates for not only more transmission, but smarter transmission.
Building on that
Please.
point, I think that there's a big opportunity in nuclear energy to use AI for regulatory acceleration, and part of the policy that will be needed is at the Nuclear Regulatory Commission to really lean forward into using AI and machine learning and accepting that as an approach. So I think that'll be important policy to support that. And there are companies in the private sector already working on this, including one in New York, Everstar, and NucLearn, and a couple of others out there.
I was just handed about 15 questions, and they're all so good.
We'll get through all of them.
I'm sorry that we're not going to be able to touch more than a few of them, and they're on a range of very interesting topics. I'm just going to pick out a few. Michael Willis asks about a topic we didn't ask about, which is concentrated solar, and whether that can, anybody paying attention to concentrated solar and whether that can provide any resource? No, and I think that might be your answer, Michael. At least that's my understanding. A question for Ashley from Carlo Perino. The problem with nuclear seems to be that there's still a low appetite from financiers, uncertain cash flows, timelines, and cost overruns. How can this problem be solved before SMRs become deployable at scale? And maybe that'd be from anybody who wants to answer, not just Ashley. It was directed to you.
I'm happy to take it.
Sure.
'Cause Ashley knows way more about nuclear engineering than I do, but I do spend a bit of time on this question of financing, because I think that is the key question. There are regulatory improvements that the NRC is working on to sort of speed the licensing process. There are definitely uses of AI, as you've heard, but the big question is, how are we going to finance these large pieces of infrastructure that take a lot of years to build, but also last for 80 years? I mean, we just, to the point about renewables, we're used to sort of that churn and burn type of investment cycle, and this is different. But I disagree with the premise of the question that there isn't interest from financiers in this, because I know that because some of them are in this room, and I see them all the time, and they are actively working on how do we put together that right capital stack between the developer, the technology provider, the off-taker. I can see Melanie nodding, so I know I'm on the right track, that we're going to need to put together the financing model to get these assets to FID. I have no doubt that will happen, but I don't think we should underestimate that there is work that people need to spend, time they need to spend and work they need to do to make that happen, because it's always going to be 10 years away if we don't start doing that now. And I also think, just my own view, we should be realistic about the timeline. I think there certainly are SMR developers that will put a megawatt hour of energy on the grid in 2030, but I do not think we are going to be commercializing a fleet of SMRs in 2030. I think it's going to take a little bit longer than that, and that's okay if we're going to get started now. And for us, our role here is we have, as I said, 25 reactors across the country that we own or operate on an existing site is certainly a more logical place. Some of these sites have already been, looked at from a regulatory perspective or have an early site permit. They've done a bunch of the advanced work where we might be able to have a little bit of head start on that timeline, but we do have to get that financing partnership in place, and there are discussions underway to work on that right now.
And I just want to add to that. I mean, I agree there's a lot of interest. There's also, if you look at the renewable industry, a lot of development companies were really critical to moving renewable deployments, and we're starting to see development companies in the nuclear space, which is important because that has been lacking. There haven't been project development companies. And we need those project development companies and investment banks to put together that capital stack, which is going to be complex in the future deployment of nuclear. I also think that Vogtle is often seen as a cautionary tale. But if you do a deep dive into Vogtle, which we can't do right now, it's actually it's a miracle that was finished, frankly. But if you look at it, the number of times the EPC firm changed, the bankruptcy of Westinghouse in the middle, COVID and a number of other things really came in, and they still finished that project. Once you had the right team take over, the cost escalation and the schedule delay was very minimal. Right? So you can see in the Vogtle profile that there were a lot of things that went wrong at the beginning, and then things got on track. So that's what we need to do is, in the future, do that part where it's on track.
We're down to our last few minutes. I want to urge any of you to make any points you feel are important that you haven't had a chance to make. Just jump in and make them. But while you're thinking about that, I have a question from Jason Job, who, for Melanie and Kathleen, have there been discussions related to hydrogen-powered data centers, specifically green hydrogen?
I don't think so, but you can.
Okay. Not that Kathleen has heard, right?
I'm not close enough to that part of the business, but I know that we have an incredible data center science and research team, as well as our Microsoft research team that does a range of work. So I am 2 years into the company. As I'm learning, it's quite a large company with an incredible amount of work happening. So I don't take my silence as a no, take my silence as we should follow up, or I should do a Bing search further with the team on this one.
Bill Brown from New Waters, who's a real leader in this space, has a question for you, Melanie, asking, is Microsoft prioritizing certain clean energy pathways over others?
As I described, what are the criteria for what pathways we go down, which is where is the load grow? Where is our load growing based on a range of factors: land, power, fiber, connectivity, labor, electricians. There's a whole range of business trades of where we're going to go site data centers. We've been growing these around the world, so these are all questions that we grapple with. And then it gets into what are the power sources, and I think you made a good point, Michael, which is around that access to power is a key part of the conversation. And another key part is, what does the queue look like that Kathleen mentioned? Many people are in these queues, many developers seeking to develop on our behalf, many seeking to then sell on to us in the future. And so there's a lot in those queues, so really helping understand what's happening in those queues. And then you get into the power resources that are there. And again, we set a goal back in 2020 to be carbon negative by 2030. A key part of that vision is ensuring we can power our assets with as much carbon-free power as possible. And so we have an incredible team that is out there every day hunting and finding PPAs to advance clean energy development around the world, and so particularly in both the 24 countries, if not more. So I'd say we look at many different pathways, but we remain committed in adhering to how do we do that in light with our 2030 commitments to be carbon negative.
Well, the clock is telling us that we're out of time, and even better, that it's lunchtime. So please join me in giving our panelists a big round of applause.